Hi, my name is Joanna Cervantes. I'm a high school student with Los Angeles, and today I'm on board XC Johnson, and today I'll be teaching you guys about styrofoam eating worms. As you can see here, the worms are kind of just crawling around, and you can see that there's oatmeal and styrofoam in there. The styrofoam actually has holes in it because the superworms actually eat the styrofoam. Superworms are basically just bigger versions of mealworms, but at the end of the day, they're basically the same thing. So here I have some worms that are crawling around. They're actually crawling around some oatmeal and some styrofoam. We actually have some oatmeal in here because it's a source of carbohydrates which they need to survive. But we also have a piece of styrofoam in here. If you look closely, it actually has holes in it, which means that the worms have actually been eating it. And interesting enough, these worms can actually digest the styrofoam and go throughout their entire stage of metamorphosis because they have a bacteria within their gut that allows them to break down the bonds within the styrofoam and turn it into an organic compound. So similarly enough, there's actually termites that they break down wood and turn it into an organic compound. It's kind of the same concept. And as for the metamorphosis, they're actually able to go throughout the entire stage. As you can see here, they're actually in the larva state, which they can actually continue into the pupate state and then turn into a beetle that's like the one that you see here. After the beetle state, they can actually mate and make more eggs, which will turn into more of the larvae.
Hello, my name is Kevin.
And my name is Jose.
We are high school seniors in the LA district.
And today we're going to be talking about a little bit of ecology, and we're going to be talking about microplastics and more specifically how they impact human organs and other marine organisms.
So first, we gotta know what a microplastic is. So a microplastic is any type of plastic smaller than 5 microns. So here we have styrofoam. So if you look at it from this way, it's very tiny, so you can't really tell how much it is. So this would be considered a microplastic. There's also macroplastic, which, for example, there's this bottle cap, which is a much more bigger piece of plastic. So microplastics start off just like any other plastic, so water bottles, caps, anything like that. And the way they become smaller is through the ultraviolet rays from the sunlight when they get direct impact, or when they're early in the ocean and the waves hit directly onto them, which makes them break down into smaller pieces. There's also synthetic type of microplastics in facial cleansers or in other hygiene products, but which are luckily now banned, which took effect last year.
Microplastics and plastics can enter any type of environment, including the surface of the ocean, for example. They can also be found within the actual waters of the ocean, and they can be found on the sand. For example, on a windy day, those plastics can eventually travel through the surface of the water and make it onto our beaches, and unfortunately we end up with contamination such as the picture shown here.
So first we are going to show you our sample of a sand sample of Long Beach sand. So here we took this directly off of the coastline. So if you take a look here, like I already showed, there's a big bottle cap, there's styrofoam, there's bark, which is natural, there's also little shells, which is natural, but what you could take a closer look at is, if you take a very close look, you're going to start seeing these small little circles. Some of them are spears, some of them black, most of them are white, some of them are gray. And what these are they're called nurdles, and nurdles are basically the starting form of all plastic, which companies ship out to different areas so they could melt them and make them into anything they want. So for example, they'll get these clear little nurdles and they'll melt them into plastic bottles, or they'll get these black ones and they'll melt it to make the chairs for schools and such things. So if you take a closer look at the sample, there's a lot of things that are biotic and abiotic. So biotic is anything that's living, so we're biotic. Animals are biotic. Anything that basically has a heartbeat or is living is biotic, versus abiotic, which is something that is non-living. For example, plastic. Here's another piece, more styrofoam.
And then next up, we're going to talk about how this impacts our humans. So the easiest way to explain it is through a process called bioaccumulation. And simply put, let's say you eat, for example, a fish, let's say a salmon, right? So you eat the salmon, but then the salmon could have potentially eaten a piece of this plastic. So theoretically, what can happen is you're not only eating the salmon, you're also eating the plastic that's within the salmon. And so why is this bad? Well, this can be mostly bad for two reasons. One, I mean, you don't really want plastic in your seafood, but the second reason is a lot more harmful, and it's because a lot of people don't really know this, but BPA is one of the main chemicals found in plastic nowadays. And BPA stands for bisphenol A, and it's basically a toxin, which Kevin will talk a little bit more about later. But essentially, it's a chemical that makes plastic a lot more hard and a lot more able to use. So, for example, this pistachio ice cream container could have potentially had BPA inside of it, and so that's why after it becomes microplastic, such as a nurdle, after it gets ingested and it enters into your body, that's when a lot of the times it can cause a lot of harmful effects, such as hormone disruptors. So, for example, estrogen and testosterone. And however, BPA has mostly been found to affect the estrogen. And what that means is that plastic and the BPA actually mimics as estrogen, and it can kind of cause a lot of different hormone disruptions within your body.
So like Jose said, there's a lot of things that are harmful about plastic. Another thing is the accumulation of toxins. So in this lesson, we're talking about chemical toxins, and one of them is BPA, which Jose just explained. But there are other toxins such as DDE and NP, which are also found in the ocean. Oil spills, dumping of illegal things off boats, many things like that causes toxins to enter the ocean, and plastic is basically a magnet for all of these toxins. So the toxins basically accumulate on plastic, and if fish start eating these plastics and then we start eating the fish, those same toxins are going to enter us. Another example is this sample of a gyre. So a gyre is basically the currents of the ocean, and there's 5 of them in the entire world, and the Alaskan currents come down to the Pacific and then they go back up to the Atlantic. So it's basically like a whole system of currents in the ocean. And here is a sample of one of those gyres. So if Jose opens it up, and we can take a look of what's inside.
Well, as you guys can see here, we have a lot of different plastics. Here we actually have a liquid beverage container, and then here we have a couple of corn nuts, a couple of snacks. But here we also have this piece of styrofoam, which you guys can see right there. Now, the reason why styrofoam is actually one of the most harmful is because let's take this small piece right here, for example. If we were to break this into smaller pieces, to a fish or an albatross, for example, this can look like a fish egg, and a lot of the times fish eat these, and a lot of other different marine organisms eat these and think that they're fish eggs. And so what can happen is they end up eating them. They eat a lot more of them because, you know, they think that they're food. They think that they just ran into a big feast. But however, they are actually eating styrofoam. And the main reason why this is harmful for them is because they don't know that they're eating styrofoam. So they don't know that they're not really eating food that they're not supposed to. But the thing is, once the styrofoam and the plastic gets into the system, they start feeling a lot more full than they normally would if they would have eaten regular food. And not only will that cause them to not eat a lot more actual foods, but they'll also cause their body to kind of start breaking it down a little bit more, and eventually they can potentially die either from the toxic chemicals within the plastics, or they can die from pretty much not getting enough nutrients that they actually need to survive.
And now you may ask, like, where is the evidence? And this is the evidence. This is a bolus, and a bolus stands for a material content of a stomach. So in this case, we have a seabird bolus, specifically an albatross bird. And albatross bird is
it's pretty much a gigantic bird. Here's a picture of it. It has a 6-foot wingspan, and it's actually what's referred to as a surface feeder. But essentially what we have here is an albatross bolus, as you guys can see here. And essentially what this is as Kevin mentioned, some contents of an albatross bird. However, you guys may be thinking, how did you guys get that, or why is there a lot of this green stuff around there? This green stuff is actually a lot of potentially fishing line. This green one here is fishing line. A lot of people don't actually know this, but fishing line is a lot more common nowadays to be made out of plastic. And the reason why is because plastic is cheap, it's affordable, and let's say a lot of fishermen go out and they get snared or snapped a lot of the times. Plastic is really cheap, so it's really affordable to kind of reuse. But the thing is, a lot of these animals don't actually know, or a lot of these marine animals don't actually know that we go out there and fish and kind of hunt them down. So a lot of the times they will think that this is food. And as I was mentioning before, albatross are surface feeders. So Kevin, do you mind telling us what a surface feeder is?
So surface feeder basically is they feed on the surface of the ocean. So albatross bird will glide in the air and look down at the ocean surface, and whatever it thinks it's food, it's gonna dive down and get it and then take it in. And for example, in the actual bolus, we have nurdles, which I talked about and explained. So nurdles, to them, they may think it's fish eggs, they may think it's squid eggs, they may think it's eggs of any kind. So they're gonna start diving and getting them, which is something that's harmful to them because they can't digest it. And what's even more harmful is that the adult albatross go out for a week or so and they start consuming all these foods so they could come back and feed it to their young. They regurgitate it in a protein-based mixture in their stomach, but the thing is that they're also feeding that same plastic that they got to the young, which are causing them to die, and this is decreasing their population at a fast rate. So Jose is going to show you some of the things that are getting fed to the young and some of the things that are found in the albatross bird.
So as Kevin was actually mentioning before, there's a difference between abiotic and biotic materials. This, for example, is a squid beak. Now squids would be the biotic portion of the, I guess you can say, the meal that this albatross had before it died. So albatrosses, as I was mentioning before, they are surface feeders. So essentially what they do is they kind of fly around, and then whenever they see like a fish or something, or a squid, for example, on the top of the water, they kind of dive down and then they kind of swoop in there and just kind of catch their meal. However, plastic and microplastics, as you guys can actually see here, tends to float a lot of the times.
So the food chain is basically the hierarchy of what's basically who eats who. And humans are at the top of the food chain versus a small little animal such as a little lizard, a little insect. Those are at the bottom because they feed on grass, they feed on natural things, and then a much more bigger predator is going to eat that, and then another predator is going to eat that, and basically the nutrients from that small little animal or that small little insect is going to travel up to the bigger predator. So that's how nutrients gets passed up the food web or the food chain. But in our case, since we're all the way at the top, we eat basically anything that we want. For example, in this case, the food web in the ocean, there's going to be small little clams, small little shells, and then bigger animals are going to eat that, and then much more bigger animals eat that, and then of course we eat those big fish such as tuna, salmon, and all those other animals. So imagine if a small little animal in the ocean eats a piece of plastic and a much more bigger animal eats that fish. So that plastic is going to go to that animal, and then we're going to eat that same fish. So the plastic's going to bioaccumulate in the fish, and then it's going to end up in us. Now we may not notice it because it's so tiny or it's not affecting us directly.
Another thing that can also happen within the food web is that, let's say for example, as I also mentioned before, the albatross doesn't give the food to his babies. Then that means that the babies are going to die, and then the albatross population is going to decrease. So what that means is that there are no more albatross to eat the squids, which means that the squids are eventually going to increase in population. Now what this can happen is this can have very different effects on our ecosystem, one of them being an overpopulation of squids and a decreasing population in albatross. But however, this can also potentially lead to an effect on our life because there's going to be a lot more fish and a lot more squid in the ocean, and there's not going to be as many birds. Now, birds, they do play a very vital role in our ecosystems, as do squids do, but that's just one of the things to take into consideration when we're dealing with so many different types of plastics. Once you mix in abiotic organism that's not necessarily supposed to be in there, once you mix in an abiotic organism that's not really supposed to be there, then that can mess up a lot of different things on the food web, causing our environment to kind of collapse.
Thank you for listening to our lesson.
If you're watching this as part of an assignment, please write these 3 questions at the bottom of your paper.
What is a microplastic?
Why is it harmful to all marine organisms?
And last but not least, write a short 5 to 7 sentence summary of what you learned today.
For more information, you could visit www.lamitopsail.org.